Good evening, everybody, and welcome to the highlight of TWed for the for every term, the end of term lightning talks. These are the spring 2021 Tetherless World Lightning Talks. Um, for those of you online, we are recording these. We will share them via our Tetherless World YouTube channel soon after the recording is produced. The simple rule is that you keep it to 2 minutes. We in theory, you're not working with notes. There are no slides, and you're uh, explaining whatever it is you've decided to do your lightning talk on. Thank you for all of those who uh, have signed up ahead of time or are joining us. That's okay. Just put your name on the thing. We've got a few people who are new to this lightning talk experience. So enjoy the show. You'll get a good overview of the work that the graduate students of Tetherless World are doing. And with that, take it away, Sabir.
Thanks, John. Um, all right, so I'll start now. So how can we design an AI system that can support healthcare physicians by reasoning in a similar way to how they reason? So physicians often employ hybrid reasoning when they're trying to address clinical decision-making tasks. So that means that they're using multiple forms of reasoning, such as deduction, abduction, induction, um, validation, abstraction, and so on. So in order to support these clinicians, we want to create a hybrid reasoning system where we compartmentalize each type of reasoning that's used, but we also want to do it in a way that is similar to how physicians do their reasoning. So the select and test model is a epistemological framework that incorporates multiple types of reasoning kind of in a circular form. So we're using semantic technologies to build a hybrid reasoner that can reason in a similar way to clinicians by kind of mimicking the select and test model. And in doing so, some of the challenges associated with doing non-monotonic reasoning, like abductive reasoning, where you may have more than one answer, is that can you do this in a way that you'll actually get a result? The result will be returned in a reasonable amount of time. Um, the result will be sound in the sense that it makes sense. Um, and stuff like that. So we'll be exploring all of these things and hopefully come to um, a pretty cool system in the process.
And stuff like that. Thank you, Sabir. The one thing I forgot to mention is we should uh, thank everybody, thank each speaker as we would like to be thanked ourselves. Thank you very much, Sabir. Um, Next is Shruti. Take it away, Shruti.
Thanks, John. So, 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 hi everyone. I'm Shruti. Um, and I am a PhD student in the computer science department. Um, mm, and I am advised by Professor Deborah McGinnis. I'm funded on the HEALS project. My research is shaping around to be my research is to support a diverse set of user-centric explanation types within within the setting of healthcare. The research question that I'm trying to answer broadly would be how feasible and useful is it to introduce explanations in how feasible and useful is it to how feasible and useful is it how feasible sorry how feasible and useful is it to introduce explanations in clinical settings? Um, and since the last time we spoke where I mentioned and since the last time we spoke where I mentioned the explanation ontology, um, um, a general purpose encoding of the explanation types, sorry, we have we have identified a concrete use case in a type 2 diabetes setting, um, to introduce explanations. And since then we have begun to work towards and since then we have begun to work towards and since then we have begun to work towards and since then we have begun to work towards and towards and towards and we have begun to work towards an end-to-end explanation generation pipeline, as initially as a proof of concept implementation. We have we initially as a proof of concept implementation, we have identified different contextualization dimensions along which clinicians are most likely to ask probing questions. Um, and 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 that is something that which we are 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 working towards addressing. I'm sorry that I cannot say more about this work, since mm, since the work is not yet published. Future plans are to continue to improve the modules in this pipeline, um, and to work on conducting and reporting human-centric evaluations of the explanations. Thank you.
Thank you, Shruti. All right, Sola, take it away.
All right. So in my recent research direction, what I've been trying to do is explore the ideas around context and how it might be usable for providing recommendations and explanations. So an example that I kind of can go to that I've brought up in some of the previous lightning talks I've given is the idea of, say, substituting an ingredient in a recipe. Depending on the context of the recipe, there might be different options for what ingredients are actually good substitutions. And this might also include some different ideas like the kind of functional processes that are going on in the recipe, the other ingredients that are included in the recipe, or maybe also some context about who you're actually making a recommendation for. For example, someone who has different preferences or restrictions on the kinds of ingredients they can eat, or some different goals for why they're actually performing a substitution. And so there's a lot of different levels of context that we might want to consider for something like, say, providing recommendations. And most of the time, this isn't actually very clearly defined or used in existing work. Context usually is kind of just included as an implicit dimension in, say, making embeddings or whatnot. And being able to use it in a more explicit fashion, I think, would be able to help with providing more interpretable results, as well as providing some explanations about some of the processes and knowledge that's used to actually come to whatever decision. And so in the work that I'm hoping to be working on during the summer and onwards is trying to define some explicit ways to capture and represent different levels of context, and trying to use that to provide more effective recommendations, as well as providing explanations to people that actually ties into that context, and drawing on examples from, for example, knowledge graphs to provide more interpretable AI that hopefully will be able to bring more trustable results. Thank you.
All right, thank you, Sola. All right, next we have Ahmed. Take it away.
Hello, everyone. My name is Ahmed Elish, and the project I'd like to talk to you about is work we're doing with some folks at NASA Science Mission Directorate, SMD. What they do at NASA SMD, that's the part of NASA that's responsible for storing and disseminating all sorts of mission data, mission-related data, scientific data acquired through all sorts of NASA missions. And their work is divided into broadly four areas: Earth science, and then you have planetary science, astrophysics, and heliophysics. And as you can imagine, across many different missions and research areas, they have all sorts of data sets and data services that are made available to researchers and to the public. Also, being a publicly funded organization, they have to do that. And as you can imagine, it's mostly structured data, a lot of measurements and so on, but it is of all sorts of heterogeneity. So all sorts of different schemas and so on, throughout the years. And what we're trying to do is we're trying to provide a unified way that people can discover data that is made available by SMD in a manner that is facilitated by some conceptual model, something ontology-led, for example, with maybe faceted browsing, because as you can imagine, some of these data sets may serve two different things, like planetary atmospheres may cross two different divisions. And so it might seem like an information retrieval exercise, but it really is a data discovery, enabling data discovery and unexpected scientific benefits. Thanks.
All right, cool. Thank you, Annette. Next, we have Jason.
Hi, good evening. Right. So hi, this is Jason. So today I'm going to talk a little bit about the project that I'm going to work with as a IBM internship for this summer. So the basic idea is that so for natural language understanding, actually we need sometimes we need more world knowledge, especially when we are dealing with some domain specific applications. So the research question in the project is to think about what's the best way to combine world knowledge, which are stored in the knowledge graph, with the lexical representations for the test. So for the lexical representation, as we know, we currently we can actually pass the natural language sentence into some logical formats called AMR, abstract meaning representations, to get some ideas of like what events occur in the sentence and what entities and what are the relations between the entities. So, but this is just a kind of like within sentence representation. But in order to better understand what a piece of text means, we need to get more context information from the knowledge graph. So the project goal is to explore some ways to like first grab the lexical representations from the text and then link some of the entities or some schema relations into the knowledge base so that we can actually construct a larger graph contains all the context information that we need to pass the sentence, and also supporting some advanced reasoning instead of like implicit reasoning doing by using the neural network to promote the explainability for the pipeline. Yeah.
So, all right, thank you.
Thank you.
Context seems to be a theme here.
Yes.
I don't think Feifei is listed as next, but I don't think she's on yet or now. Mitchell, next is you.
Okay. So hi, I'm Mitchell. Last time I did this, basically talked about the same thing. I've continued work on my domain agnostic computable policy tool. So let's go back, review that. So basically what I've been working on for past year and a half has been a domain agnostic tool for the formulation of guidelines in computable, machine readable formats. And the idea here is if you have something like a guideline for like in a medical setting, like diabetes patients, or in a access control setting, like if a lot of the time they have there's a like resource access in databases. The idea is to create a system. There's a framework that has been created by a lot of people and worked on by a lot of people here at Tetherless that supports the use of knowledge graphs. And this framework supports the use of knowledge graphs and reasoners, but the problem is it didn't really have a tool to go along with it. And the goal was to create a tool that uses this framework and then also provides the abilities to leverage any domain. So just by inserting any knowledge graph, or at least like making that a future goal, at least making that a focus of domain agnosticism, just pushing for you can use this framework within any domain, and just highlighting that in making the tool shift for any domain. That was the goal of the tool. So yes, that was a little poorly explained at the end there, but
A lot of any domain, any policies, any graphs.
Yeah. And the cool thing about it is, though, that the policies themselves are knowledge graphs, so they support reasoning, and like reasoning within like OWL. Like they're pure OWL. It's not like some other existing policy frameworks. Like we just published the paper on ADAPT as like. ADAPT is the name of the policy tool. It got a nice name because it's a domain agnostic policy tool. So we just published that paper, and it's looking at all the existing policy frameworks. It's the OWL plus Prov framework, which is the one developed by Tetherless. But the framework itself has not been published yet. That part is really interesting because it provides a lot of capabilities that other frameworks do not.
All right. Yeah, it rocks, definitely.
I really wish it was published because then I could cite it more. And then...
Well, yeah, you can help. You can help. You can work with us to get that sucker published in some way. The problem is the appropriate targets that you know, upset the legacy scientists, the grouchy legacy scientists. Anirudh, you're next. Take it away, man.
Hello. Yes, so hi everyone, my name is Anirudh Prabhu. I've been here a while. I'm probably about a couple of months to defending, so yeah. All right, so what I'm going to be talking to you about today is sort of a thesis contribution of mine that has emerged over the last 3 months when I was working on some other stuff and observed some interesting things, right? So as most of you have probably heard me talk about my thesis and stuff, there's a crowdsourcing component involved in my thesis, where I use crowdsourcing services like Mechanical Turk to ask them to do certain tasks. In this specific case, it's write rules for a given narrative, for a story, a fictional story, right? So I did that, got those results. I was examining those results and noticed some very interesting things there, which was that, you know, crowdsourcing results have so many various biases, so many various aspects. People come from various backgrounds, and that leads to sort of inconsistencies in the results provided by crowdsourcing. And so while I was looking at this and sort of, looking through the history of crowdsourcing, of humans in the loop in artificial intelligence in general, a few patterns and a few interesting findings began to emerge where, through the history of crowdsourcing, you have initially people are like, oh, can you look at these images and classify them? Which one's a cat? Which one's a dog? Or can you draw a boundary on the objects that you see? Or, what is the sentiment here for this classification or tagging? And as that progressed, we were like, by the way, can you also annotate the sentences that I'm writing? Or can you tell me a description or a caption for this image? So the complication or complexness of the tasks being assigned to the crowdsourcing participants slowly started increasing. And, most people also know familiar with what's called citizen science, where science enthusiasts who are not officially scientists are going and finding minerals, going and finding fossils, and they're really documenting that, in a scientific manner for actually scientists to take that and use it for their further analysis. So as the complexity of tasks for humans in the loop has emerged, there are like inconsistencies, complexities arising for those who are trying to analyze these things. So that would be people like us, people like me in particular. And the problem here is that there are experts in the loop that we have been using for a long time, say for ontology design, right? There are experts who make decisions on what those rules are going to be, and they not only know about the domain, but they are also experts in the field, it's in the language itself. So you're writing, say, OWL rules or restrictions, then you know about the language. You're writing situation calculus rules, you know about situation calculus. But this concept doesn't really exist per se as, experts in the loop workflow and humans in the loop workflow, because no one's really looked at it in detailed and in a big picture level enough to form the boundaries of this field. For a framework of what constitutes humans in the loop in AI, what are the limitations of this approach? Where would be a good place for it to actually only have experts and not sort of crowdsource it out, or to have general people evaluate these things? So because I hit that issue while I was analyzing it, I was sort of forced to look into all of these things and document some of the boundaries and the limitations that I perceived, which kind of resulted in a separate thesis chapter and potentially a separate paper in itself. So part of the future work of this is going to be to look at this in a lot of detail to create this a framework for experts in the loop, and what is its usability, what are its limitations, and how far can we go with that? So that's what I wanted to talk about today. Thank you.
All right, thank you. Oh, darn, another paper possibility. Okay, Matt.
Hi,
Matt.
I'm Matt. Yeah, I can go.
I'm picking on you. Go ahead.
All right. Hi, everybody. My name is Matt Johnson. I'm a third-year PhD student under Deborah McGinnis. As kind of highlighted by the previous presenters today, knowledge graphs are an important technology. They enable a wide variety of analytics and data visualizations across an entire enterprise of data. But creating them and adding onto them is challenging because it requires a certain set of skills that not many people have. And so my work is focused on reducing this barrier and developing an algorithm and also a UI that suggests alignments between a user's data and a desired knowledge graph. This allows users to become alignment reviewers instead of knowledge graph producers, and allows them to more easily contribute to them. Currently, our algorithms perform around 20% better than baseline on suggesting different alignments. but this can always be improved. And kind of the challenge going forward is that to improve performance, we need to actually increase the amount of data, because there's a direct correlation between those. And unfortunately, few data sets actually exist. So for the next, my next steps going forward, I'm going to start addressing this. I'm going to be looking at developing simulated data, reverse engineering tables and data sets from knowledge graphs. So I've been starting to go through and look at existing knowledge graphs such as DBpedia and developing Sparkle queries to generate tables, and generating the corresponding data dictionaries using property descriptions and ontologies. My hope is that as I increase the data going forward, my alignments will get better and better and reduce the load on users. That's me.
All right. Thanks, Ben. All right. Let's see. We still don't have, probably won't have Feifei on, so it's NECA. Go ahead.
Hello, I'm NECA. I'll be talking about my work, which is automatic image description, especially within the area of chest X-ray. I guess my work is the first that isn't really knowledge graph driven yet. So now we're using GCN, graph convolutional networks, to be able to find the relationship between the anatomical regions of the chest X-ray. Moving forward, we're looking to create a time ontology for chest X-ray. We want to be able to follow how radiologists read the X-rays. So we want to be able to follow it from within a 3-month time frame. We also want to be able to use the ontology and the knowledge we generate from it to be able to predict diseases that cannot be found on the X-rays. So we're focusing on kidney failure. We know that there are symptoms of kidney failure that are present in the X-ray, but the X-ray doesn't really capture the kidney. So if we can detect things like edema or fluid overload or cardiac failure, can we use that to predict the risk of kidney or renal failure in future? Most of the work is deep learning, but the main semantic part of it will be the knowledge and the time ontology. That's it.
All right, cool. Thank you very much. And I'm scanning the list here of people not signed up but who are on. Julia, would you like to go? Julia? There she is. Oh, back on mute.
Julia's a new student with us. She's not officially.
I'm sorry.
No worries. I think she's just kind of here to watch us.
That's perfectly fine.
Right.
As are you, Rebecca, as is Yolanda. Yolanda's probably going, do I have to talk?
Well, I think the opportunity's there if she wanted to.
Yeah. Well, I think that's it. We'll get an early quit. I think there's a number of people who, for whatever reason, couldn't make it tonight. And so thank you, everybody, for thoughtfully presenting these lightning talks. As everybody give each other a hand. If there's students that you didn't have an opportunity to hear tonight, please, but want to update on their work, please contact them and have a chat. These lightning talks are a great opportunity to just kind of get together and once a term and just get a real fire hose update of what everybody's working on. It's really a great thing. Unfortunately, we couldn't have any of the professors with us tonight. Deb is still on vacation, just coming back later this week, and Jim Hendler's doing what Jim Hendler does. But thank you, everybody, and hope you have a great end to the semesters and a great summer. And take care.
Thanks, Joe.